So we'll go on to this one. What it says is that if A is greater than B, then print A is greater than B. So here there are two logic there. Number one is that the condition one is that A is greater than B. So it's a 200 greater than 33. So print A is greater than B. Okay. But what if that is like the other case? For which that we have got here,停咗 share screen 啊？係，等一陣，停咗 share screen。哦 ，share screen，等一陣啊。Okay. So this one is okay, right? You can see the screen again. Can you see the screen now? Okay, hold. Okay. Now we have got one line that if the else statement, so we have got three conditions. So we try to have it again. It's like A is equal to 330, B is equal to 330. What it says is that print A. If A greater than B, else prints equal. If A double equal B, else print B. Okay, so it's like, well, what kind of things they try to talk here? Okay, so see what it happens in the screen. We print out what? Just one equal sign there. Why? Okay, print A triple if A is greater than B. We just chop it out. A is not greater than B, right? A is just equal to B. So therefore, we just go into second condition. Else prints equal. Okay, so that we have got equal. Because actually it is not A greater than B. If A double equal B, else prints B. Okay, so here we just print out the equal sign there because of the fact that the first statement say A greater than B, else then we just print the equal sign. So therefore, in this case, that we have got the equal sign there only. Okay, and then if you go to the next one, then we have got AND logic. We just try. A is equal to 200, B is equal to 33, C is equal to 500. So if A is greater than B and C is greater than A, then print both conditions are true. So try to run it out, and then A is greater than B. So by logic, A is greater than B, correct. Another one, C is greater than A. 500 is greater than 200, also correct. So if these two are correct for the AND condition, it means both of them are correct. So you have to print both conditions are true. So both of them are correct, so that both conditions are true. So that is why they appear as something as such. Okay. In the case of OR case, so test if A is greater than B or A is greater than C. Okay. So at least one of the condition is true. So because of the fact is that A is greater than B, yes, 200 is greater than B. Or A is greater than C, 200 is greater than 300 is incorrect. The second condition is incorrect. However, because the first condition is correct, so therefore, it fulfills the criteria or where A is greater than B. So still that you can see is that at least one of the conditions is true. So another example, x is equal to 41. So if x is greater than 10, print above 10. If x is greater than 20, print and also above 20. Else print not above 20. So we just see x is equal to 41. If we go to the first condition, x is greater than 10, right, correct, okay, print above 10. If x is greater than 20, print all and also above 20. So what we may expect is that if we print out what? Above 10 and above 20, because not else. If it is not above 20, because this one is obviously above 20. So for what the statement behind else will be ignored. So see whether or not it is correct. Above 10 and also above 20, because for the statement it is above 10. 41 is above 10. 41 is also above 20. So therefore, that ultimately it has got two statements there. And then the past statements, the if statement cannot be empty, but if for some reason that you have got an if statement and no content, then put in the past statement to avoid getting an error. So you have to try yourself here. A is equal to 33, B is equal to 200. If B is greater than A, then pass. Having an empty if the statement like this would raise the error without the pass statement. So here you will see that B is greater than A, for which that it is a pass, it should be a pass statement. However, according to what is said there, the if statement cannot be empty. Okay, so that for the pass statements is to avoid the but if you for some reason that you have got a if statement with no content, okay, so you just put a pass. So it's a pass is just like what it's just like by the time you pay if you know what is so if you play and then you may just say that I skip this time, so that you just say pass or to the next one. So it's very similar to that, and then you try to avoid the error statement. As otherwise, then if the statement is not there, then probably if A is greater than if B is greater than A, then you should have got a statement. For example, you will print what? Just like previously. If x is greater than 10, then print above 10. However, there is no such print 10. For example, if B is greater than A, print above 10. There is no statement as such. If you do not have a pass statement, then you will just end up with error. So we try to experiment with that. You just have got no pass there, and then you just have got run, then it should have got error. It should end up, yes, error. Okay, trace back, blah blah. Okay, syntax error, unexpected EOF while passing. So that's why that the pass statement is try to avoid the error statements. Okay, and then Python while loops. Okay, try to exercise by yourself. Okay, print hello if the A is greater than B. So we try to see it. Okay, if A is greater than B, if A is greater than B, so print. So you try to submit answer, and then you try to submit the answer. So it said it is correct. Okay, as simple as that. Okay, and then you just go to the next one, while loops. Okay, Python loops. The Python has got the loop command, while loops, and also for loops. Okay. I is equal to 1 while I is greater than 6, smaller than 6, print I, and then I is plus equals to 1. Okay, what does it mean by plus equals to 1 then? Let's try the experiment. What is that here? I is equal to 1 while I is greater than 6. You can see 1, 2, 3, 4, 5, no 6, because when I is smaller than 6, print I and then plus equals to 1. So you can see that each of the single time is what? It has got a difference in 1. Okay. If you are not sure, then you can try to use another one when I is less than 10. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. However, if we try to use like not +1, but then we try to exercise with the 2, and then we try to run it again, 1, 3, 5, 7, 9. Why? We set it as like plus or equals to 2, so that it should be 1, 2, 1, 3, 5, 7, and 9. And then we have got 100, for example. Then we run again. You can see that we have got all the number there. Okay, print it out until 99. Okay, because it's like the difference is like 2. The break statements, so exit the loop when I is 3. So I is equal to 1, while I is less than 6, colon, and then print I. So if I is equal to 3, then break. So here we try to break out the statement, what is trying to mention here. I is equal to 1, while I is smaller than 6. So it's 1, 2, 3, 4, 5, okay, in the second line statement. So we try to print out I. If I is equal to 3, then break. So it means that in the second time, it just say that, well, it will just print equals to 3, then it stop. Okay, for the break in itself, it just means stop. For every single time that there is a 1 in difference. Okay, so it is what is mentioned here, that you have to follow each of the statement there and then end up with something. So another one, I is equal to 0, and then while I is smaller than 6, I plus or equals to 1, and then if I is double equals to 3, continue and then print. So what it says is that I is equal to 0. So when I is less than 6, then you just add 1 beyond that, okay? If I is equal to 3, you still continue. Now, not break in this time, you still continue, okay? But then you may find that is that number 3 is missing as a result, because what it says that if the I is equals to 3, okay, so you just continue. So it means that you just pass that number 3. So number 3 therefore is not there, okay? So that we have got other, okay, we have got other than that's I is equal to 1, print I is more than 6, and then print I, and then I is plus equals to 1, else print I is no longer less than 6. So I is equal to 1, and then while I is smaller than 6, and then you have to print out I. So it's a 1, 2, 3, 4, 5, okay? And then I is plus 1, and then else print 1 I is no longer less than 6. So you have to print out all these, okay? And then so that you just print out this, okay? Because, okay, if I is no longer less than 6, okay, so you have got the statement that is printed out there, okay? So you can just say as if, like, for example, we just change a bit, that we change to 16 instead of 6, okay? And then plus 1 we change to plus 3, and see what happened. So we have got what? Each of the single time, it adds 3 on top of that. So it's 1, 4, 7, 10, 13. But then here, we just make it a statement as that I is no longer less than 6, okay? That we should be like making it changes as a I, print I is no longer less than 16 instead. So it just have got a new statement there. I is no longer less than 16. Okay. And then we have got the exercise by yourself. I is equals to 1. So what we have to do is that while I is less than 6, print I. Submit answer. The says is correct again. For loop, okay. For loop that we have got like apple, banana, cherry. So print X in fruits. So we have to print X apple, banana, cherry. So we try to run it. Okay. We have got print all the X in. Okay, X in the fruits. So therefore that they have got like 3 types of fruits are there. Looping through a string. So each of the string is iterable objects. So they contain a sequence of order. And then for X is in banana. So we have to print X. So you can see that all the X are what represents a one alphabet. Okay, so that you just have got this print out. The break statements. Fruits is equal to apple, banana, cherry. For X is equal to fruits, so we have to print X. Okay, if X is equal to banana and then print break. So we have got what? Apple, banana, cherry. So if X is equal to banana, break. So it means that it just stop in banana. So therefore you can see that there are 2 fruits, apple and banana only. No cherry here. X will loop when X is equal to banana, but this time that the breaks comes before print. Okay. So we have to exercise here apple, banana, cherry. So if X is equal to banana, then you just print, then you just break it. Okay. So no more banana, but then you just print out and then you can see that there's an apple there. And then we will go to something for which that there is something that is a numpy. Okay, we will go to numpy. Now, why will we go to numpy? Because all the most of the statistics econometrics model that is involved, that is one of the major package is numpy. All the almost all. Okay, it is very strange, but then a lot of the package for the Python that you try to use it for econometric modeling that involve NumPy. So say for instance NumPy that even involve for like machine learning, we also use NumPy as a base and then add in some other thing else and then become the machine learning model that we have got. So NumPy is actually a Python library used for working the arrays. So it also has functions for working in the domain of the linear algebra, Fourier transform, matrices, etc. So that is made in 205. So why NumPy? Because we serve a number of purposes of arrays, but they are slow to process. So we have to use a NumPy. So NumPy is actually faster than other things like the list that we have included there. So even though that we have not covered all, okay. So NumPy is actually was written in C in itself. And where is the NumPy code base? We have got this one, okay. So getting started. So we have to import NumPy for the Python. We usually need to import something first before we can do everything else. So we have to import NumPy. So tell the computer that we have to include this package. So import NumPy and then array is equal to NumPy 1, 2, 3, 4, 5, and then print ALR. Okay, so here we have got the NumPy and then we have got array and print array. So we have got 1, 2, 3, 4, 5 there. And then check in NumPy version, so you can check which version it is. Why do we have to check the version? Because some of them are incompatible with other package. So you have to print np dot version. So we have got the version there, and then we have to create some of the arrays. So import NumPy as np, and then np array 1, 2, 3, 4, 5, and print array. So we try to print the array out, and then print the type of the array. So what is the type of it? Is it number? Is it the is it other thing else? So a class is a NumPy and the array. So you just said that it is NumPy's and the array because it actually is a class of this. How can you can use the tuple to create a numpy array? So you have to use like import numpy as np and then arr is equal to np array 1 2 3 4 5 and then print arr. So what you have to do is that you try by yourself and it's on 1 2 3 4 5. Okay. Dimensions we have got like we try to calculate, we try to use the arrays, we try to create the array with the value of 42. So we try to make it out, and then this one is like 42. Two-dimensional arrays. So we have got the, if you know the matrix, so for the matrix we have got 1 2 3 and 4 5 6. So we have tried to print it out. So we have got 1 2 3 and then 2 4 5 6. Okay, so this is a kind of matrix. So for those who do not have the economics as a background, or you have not studied economics before, then you may not know what matrix is. So for the matrix is it's actually a kind of the you may consider that we have got like two lists that is available. So we have got list one, we have got 1 2 3, and then another list we have got 4 5 6. So we have got two different lists. So there's a kind of like array for which that we have got in computer science, and that's actually something that is similar to the matrix in the econometrics in itself. 3D, three-dimensional. So we have got 1 2 3 4 5 6, 1 2 3 4 5 6, for example. So if you try to print it out, then we have got two arrays here. How to check the number of dimensions? So you will try to print a dot ndim. So we will know how many dimensions are all together. So what you say is that 0 is for A. There is 0 dimension, 1 dimension in B, and then 2 dimensions in C, and then 4 dimensions and then 3 dimensions in D. So you just tell you that the dimensions that is involved. The higher dimensions, so if they just say that array np.array 1 2 3 4 and then n admin is equal to 5. So you try to print out. So you try it by yourself, and then the number of dimensions will be 5 there. Okay, because it just say that it tried to make out the dimension as 5. So therefore that the number of the dimensions that we have got 5 there. But why that it can tell us that it is number of dimensions equal to 5? Because it just say that print, okay, open quotation marks, number of dimensions, and then a space. You can see that it also have got a space there. So computer science, you can treat the computer as a stupid idiot. Okay, so if there is a space there, it will go with a space. If there is no space there, then it will not have any space at all. Okay, and then we will then go to the next one, indexing. Okay, now there is something which is very important. Why? 2 weeks ago, I run an auto ML, auto machine learning model in my computer, and then I forgot one major thing. One major thing is that, well, everything starts with 0. Okay, for the Python, it's very strange. By the time we try to give them a rank, it does not start from 1, but it starts from 0. And then by the time that you just think that it start from like 1 instead of 0, then you just do a lot of things that is incorrect, and all the things that you try to do is like completely wrong. Okay, now say for instance for this one, import number as np. Okay, np.array 1 2 3 4 and then print array and then equals to 0. So you will try to see what it happens. Okay, 0, the index, it just tell you that it wants to have got what, the number index as 0. So which number is that? So we start from 0, that is equals to 1. Number 1, position number 1 is equals to 2. Position number 3 is equal to position number 2 is equal to 3. Position number 3 is equal to 4. So the first number is start from 0. Okay, index is start from 0. So if there is, what is that is that well, let's have got the array of 0, then it is actually refers to the first figure that will appear in the whole list. Okay. Another one that we have got the print for the number position number 1. Then we just count from 0, 0 and then 1. So it should be printed as 2 there. So let's try. So yes, it is true. Why? 0, 1, 2, 3. Okay. So for the 0 index, it is actually for the first number, that is 1. For the number 1, that should be referred to the second number, which is 2. So the access second elements on the first DIM. So we try it by ourselves. For the second element on the list dim, this is equal to 2 done. Okay. So the what is that it is like first one that you have to be the second print the second element on the first dimensions on the first dimension. So the first dimension, then it should be what? It should be the first dimension, it should be here. That is the first set of the number 1, 2, 3, 4, 5. Okay, that we have to put it as a first dimension. And then second element, it should be what? It should be like 2 then. So that we just put it as like number 1 towards the end of the statement. Access 3D arrays. So import numpy as np. So np array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have to print 0, 1, 2. So what is that? Is that access the third element of the second array of the first array. So what it print out is like 6. Okay, what it print out is 6. So what it means that why it is printed as 6, because what it said is that access the third element. So third element it can be what 3, 6, 9, 12. But then it's a second array of the first array. Okay, second array. So second array of the first array, so that this is like so it just refers to the second group of the numbers. So it's a second array of the first array. So example explains. So array 0, 1, 2, so we try to print the value of 6. And in this way, the first number represents the first dimensions, which has 2 arrays. That's 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12. So since we selected 0 and we are left with the first array, so that we have got 1, 2, 3, 4, 5, 6. Okay. The second number represents the second dimensions. Second number represents second dimensions, which also has got 2 arrays, that's 1, 2, 3, and then 4, 5, 6. So since we select 1, so that we have left with the second array only, so that is like 4, 5, 6. So the fifth number actually represents the third dimension, so which contains like 3 values, 4, 5, 6. So since we select the 2, so it just end up with the third value because of the fact that it starts from 0. So it's 0, 1, 2. So when we select the number of 2, then we have actually end up with the third value. So we have got a negative indexing, so we try to print the last element from the second dimension. So for the print out the last elements from the second dimension, then we have got the last statement. Second dimension, then it should be what? Now here we have got -1 because we want to know the last element. Okay. So the second dimension as set because we start from 0, so therefore the 1 it is refers to the second elements already. Okay, we have got a second elements already. There's a 1 and -1. So this one it come from like 10. So we have got like all these, and then we will move on to machine learning part a bit. Okay. Uh, so for the remaining parts that you can just try to read it. Okay, see what happened in the NumPy stuff. Okay, and then we will go on something more which is like much more interesting, I would say, because we have to start from the very boring stuff before we have got something that is much more interesting. So say for instance we have got a data set. Okay, we have got the database. Okay, we have got like car name, color, age, speed, auto pass. Okay, and then we have got like numerical, categorical, ordinal numbers. We have got numerical, that is discrete data. Okay, now this one is what you have to do if you run for like question number 6 and also 7. So we should have got a Excel like something like this. Okay, so for the Excel, it just tell you as like car name, color, age, and whatsoever. So we have got like we have got these, okay, these things. However, if you enter red, black, gray, white into software like for example eView, it cannot run anything. I'm not sure whether it is true now, but by the time that when I run it when I was in the PhD, the software just say that it cannot run because it cannot detect what kind of the elements it is. So you have to change all these back to the numerical value before you can do anything. I'm not sure whether it is true nowadays. So, but then what it is like good in terms of like Python is that if you have got these things, that it should be still able to run it. Okay, but for the eView, it will already stop already. Okay, it will just say tell you that well you have to change all these into a numerical figure before it can proceed. Okay, but for Python the good point is that it can handle the qualitative data. Okay, so therefore even though that you have got words, it doesn't matter. So we have got numerical, there's number 1, 2, 3, 4, 5. Categorical, yes or no, there's categorical. Okay, type 1, type 2, type 3, type 4, so there is a categorical. So ordinal, so we have got like for example in questionnaire we have got 1 to 5. 5 is the best, 1 is the worst, so it's an ordinal. So we have got numerical, we have got discrete numbers, so numbers are limited to integers. We have got the continuous data, so it's number of the infinite value. Okay, say for instance the price, etc. So for machine learning, so we start with the mean, mode, median. Okay, so in terms of describing the data, we will start with the mean, median, and mode. Okay, so we have got like 99, 68, 67, 88, 111, 66. Okay, 86. Okay, so we try to have got the speed. Okay, we want to have this. We have got the speed of the whole car, of the all the car, and then we want to calculate the mean. Then what we have to do is that in Excel, we will try to use a bracket 99 plus 68 plus whatsoever divided by 13 equals to 89.77. Okay, but then if case of NumPy, what we have to do is that import NumPy speed is equals to something, and then NumPy mean speed, and then print x, so that we have got uh, the mean of this. Okay, so we have got NumPy dot mean. Okay, and then for the median, then we have got like what you have to do by hand is that you try to put your hand and then try to calculate towards what is the in the middle. However, in case of NumPy, then you just import NumPy speed, okay, and then NumPy dot median black cat speed, and then plain x, okay. And then for using like median of the speed, okay, you do the same thing. Then you try to use a NumPy median dot median black cat speed, okay. Mode, so there's a most frequent figure. So we try to do from Spice, so from Spice import stats, okay. So there is another package, speed is equals to whatsoever, and then x is equals to stats dot mode speed, and then print x. So we try to look at which figure that is most commonly found. So what is said is that mode array, the highest one is 86. So there are altogether 3 of them is equals to 86 in terms of speed. Standard deviation. So we try to use the standard deviation that we try to calculate. Okay, so the standard deviation here, then we have got input number, speed, and then standard deviation pulling x. So we have got this one. Okay, so we try to calculate the standard deviation, and then for the multiple regression, for which you will use more often, multiple regression, then we try to use import pandas. Okay, we try to use the import pandas. So we try to read the CSV for which we have put in the cars, for example, and then we have got the dependent values. Okay, that is y. Okay, for the regression, remember that's for those who have not studied regression. Regression is that we try to look at, for example, y. We may consider y is marks of the student, for example. Marks of the student is depend on what number of the hours that he or she have studied, uh, number of grade that she has got in DSE, for example, so that it will affect y. So y that we have got is actually uh, uh, a kind of thing for which is included in machine learning model. And then there is difference between the regression and also machine learning as well. But then for machine learning, the regression is actually usually used for prediction. Okay, so what we for the regression, normally we just look as a correlation relationship, whether or not that marks and also students results are correlated. So from sklearn import linear model, so REGR is equal to linear model dot linear regression, and then we try to regression fit x and y. So we try to do it. Okay, our example. Now what it says is that try to predict the CO2 emission of a car when the weight is 2,300 and the volume is 1,100 and 1,300. So what you see is that the good point is that you try to do prediction. So what is the value of it? Stock prices prediction, housing price prediction. Then we will try to use a multiple regression of the machine learning model here. So what we have to do is that we must have got the CSV value here, and then we have got the X. We know that, for example, for this one, we try to predict the CO2 level. So we have got weight and also volume of the car, for example. And then we have got these data, and then we try to run it. So here we have got by the time that the car's weight is 2,300, then what happened is that the CO and the car weight is 2,300, volume is 1,300, and then the CO2 emission will be this one. So this is used for what? Prediction. Okay. So if you have got a lot of the variables about like a lot of variables about like different things, and that you want to do prediction, then this one is workable. So you can actually use it for like housing price prediction in question number 6, for example, and then to run it for that. And then for the lecture materials, then we will just end up here. So any questions before I leave? Any question before I leave? So if not, then we will just end up here, and you can explore the things that I have taught and mentioned here so far. So no question? So if no question, then we will just end up here. Um, for the case that if you have got any other question, then you will in case that you have got any other questions, then we will just you just send me email, etc. Okay, so see you. Bye bye.